Hello, data voyagers. I am Igor Alcantara, and I am here to talk about statistics, data science, but this is a different video because this video was not triggered by some idea that I have and something I wanted to explain. It came from you. Yes. So this video came from a question a user had at Qlik Community, and I'm here to answer, but not only answer the question, but go through over an investigation process. And while I'll do that, there's a lot of concepts that I'd like to explain. So if you're not interested in this like advanced concepts, no worry, I'll break it down. Regardless if you have experience on statistics or not, this is a very important concept. So I ask you to watch until the end. If you're not understanding something, no worries, the concepts that I'll explain by the end of the video, and I'll try to keep it as simple as possible. So in the summary, we'll check the question, we analyze the question, what data I use, everything will be available on the article that will follow this video. So if you go to datavoyager.net, there was an article where I will post the details, formulas, everything that I used. So we use Qlik for that, and we use R as a comparison. So I hope at least you're curious. So let's get to it. So this user in Qlik Community had a question about the exact mathematical formulas for skewness and kurtosis. So because in the documentation, if you check these two functions, like let's check for example this one here. So if I click on it, kurtosis, there's no formula. And if I close this and I check skewness, there's also no formula, just the skew function, kurtosis function. But then you're confused. What are these? What is skewness? What kurtosis? Why do I need to know this? When do I use this? No worries, I'll explain that. But before, let me show you the data set I'm using for this exercise, this investigation. So I'm using the student performance factors found on Kaggle. I will put the link to that data set so you can download it on these the article that follows this video as well. Now let's get to it. Let's go to Qlik and let's talk a few concepts. The first concept is the concept of a distribution. So this is a distribution, beautiful, normal distribution. And if you want to know more about distribution, I do have a video where I talk about normal distributions in Qlik, one or two videos in the Data Voyagers YouTube channel, and I show how to do it in Qlik and explain the concept. So I'm not going to over too much detail in distribution because I've already talked about it. But this is a normal distribution, and a distribution basically is a way that shows the frequency of some data of one variable. So let's say we're talking about the height of people in a given population. So I will plot every single individual height, and what we get is a probability distribution. So this is basically a probability of finding someone in that population with a given height using the statistics. This is the normal distribution. We call this as a bell shape. It's a very symmetric, it's a perfect symmetric because it tells me that most of people height, let's pretend this is talking about height, are close to the average, what we call the mean. So then we have as closer to the average you are in terms of height, the more probable, the more likely is for some people with the same height as you to be found in that population. But not all distributions are pretty like this, that we can get a lot of information, do a lot of assumptions based on that. Not all are like this. Some of them are skewed. So look at this. So I took one of the columns in the student performance factor data set, and this is what I got. Is nor symmetric. Now, how asymmetric? So that's why we need those two metrics that we're discussing today. So skewness, there's the definition here. I'll put the text in the article if you want to read it more, and then you also, of course, you can search on the internet. There's a lot of articles about it. But let me explain it. So skewness measures the asymmetry of a curve, of a distribution. So basically, how much skew that distribution is to the left or to the right. And when I say skewness to the left is to the right, think of, let's say the distribution could be like this, but then someone stretch it either to the right or to the left. Look at this. It's like I took this and I stretch it to the right. So this is right skew. So if the measure of skewness is positive, then it's right skew. If negative, then it's left skew. Will be the opposite, like a mirror of this. Why is this important? If I only measure the skewness, then I know that most of the values are concentrated in the lower side of the distribution. If the skewness is negative, then I know most of the values are concentrated on the higher side of the distribution. I can see that most of the numbers are concentrated on the lower side, but there are some extremes values that are pushing the average up. So this is right skewed. So that's the measure of skews. Remember this number, 8155, rounded to the fourth decimal place. And look at the difference between the mean and the median. So mean is the average is 1.49, and the median, they're not the same. They're actually quite different. If we look at the scale of the numbers I have, the median is 1. So median 1 meaning 50% of the values are below that, 50% of the values are above that. So be like the central line, wherever it is. So it's like here. In a normal distribution, perfect, beautiful, symmetric, mean and median are the same. If they're different, there's some asymmetry working on here. So that's the skewness. And that's the kind of the book definition or formula, which I don't know if that's the one that Qlik is using. We'll test that. Then we got kurtosis. It measures the tailoredness of a distribution. So basically, how many extreme or how extreme values we have, how extreme are the values. So look at this. I have some values that are very extreme. I'm pushing very much to that. So that's the kurtosis. So if I need to explain this in a very, very simple terms, very grotesque, it's a simplification again. So don't hate me if you are a statistician. I know this is not the book definition, but so people can understand. Skewness, you're basically measuring how thin or fat the curve is. And the kurtosis measures how much the curve was stretched, like how the width of something. So that's the difference. So that's what the user asked. All right. Why is important? Well, by those information, you can tell a lot about distribution and about a population. For example, the average salary in a given company is, I don't know, $120,000. Okay, that means that people actually make good money there. Well, let's calculate skewness and kurtosis, and then we'll find like large values. Say, well, actually no, most of the people makes very little money, but there are like a couple people that makes a lot of money. So those are kind of things that we can gather by just with these simple calculations. All right. Now, if I have to calculate this, what is the formula behind it? Because calculating, you can go to help.qlik.com. In Qlik, is basically the function for skewness is skew, and then one parameter, the field, and kurtosis is kurtosis, one parameter, the field. Simple. But there is no documentation about the formula, which is what the user asked. But you know what has pretty good documentation about formulas? Because it's used for mathematicians, statisticians, data scientists. I can say not my first love in statistical programming. My first love in statistical programming was Lisp. But my first real serious love in statistical programming R. You've seen a lot of my videos working with Python, but my true first love that I still, once in a while I do a few work with that is R. So let's go to R, and I'm not going to teach you R. I mean, otherwise there would be a very, very long series of videos. But R is a beautiful, elegant language. So I'm not going to explain what the technique, the code, but I'm explaining what I'm doing. So basically, I previously installed these packages here. That's the packages that I'm using for that calculation, the E1071. So I already installed, so this is committed. So let me simply select this line and run that line to call that library and import the library. Okay, I got the library there. And then let's load the data set. So let me load the data set. There we go. I have the student data set. Let's take a look at the student data set. So let me just take a look at the first rows. So these are the first rows, not pretty, not very pretty. And then let me execute the summary. If you notice, I'm executing row by row here on my script, and then on console, I see the results. Pretty simple to understand. Now, if I execute the summary, then I got the summary like for each columns. I see what the numeric. I see what is the minimum, the max, the median, third quartile, some statistical summary, which is basically the foundation of a box plot. All right, let me see what variables are numeric. So these are my variables numeric, and the one that I'm analyzing in Qlik is this one here, tutoring sessions. Great. Let me just make sure I'm converting that to numeric. It says it's numeric, but maybe there is like a null value or something. So let me make sure everything's numeric. It's numeric. I'm showing a histogram here, so I can say that histogram looks like the shape we saw in Qlik. Pretty good. Now, let's do simple calculation of skewness. So if I run this and do a simple calculation of skewness, let me run it. And I'm just using the skewness functions in R, and then it gives me 0.81515, If we round that to the fourth decimal place, we kind of get what Qlik has. Maybe it's a coincidence, maybe it's not. Well, let's take a look at kurtosis. Let me run kurtosis, and then we got 64122. Wow, we have a problem. 6437. I cannot blame rounding for that. It's different. 6412. Wow, it's not the same value. So let's check for the help of the functions. How do we check for the help of the functions in R? Well, it's very simple. You basically put a question mark in front of the function, and then you type the function name. So question mark skewness will give me the help for skewness, and same for kurtosis. Let's check one of them because we're basically getting very similar information. So let me execute this row. Got the help there. Let me click this function here. Then I got the help definition. Pretty good. Great. Look at this. There are parameters that I did not use, like the NA.rm. Basically, that's if I want to remove no. NA, like it's how we represent no values. RM is remove. Do I want to remove null values or not? Actually, interesting. I could apply that to make sure I'm removing null values. Spoiler alert, in this particular case, it doesn't change much because I do not have null values. And then type. This is interesting. We have a type parameter, and we basically have three types. And this is a definition, and basically type 1 is like an old text definition, textbook definition for skewness or kurtosis. Type 2 is what we use in these softwares, SPSS and SAS. And type 3 is what we use in Minitab, BMDP. And type 3 is the default in R. But which one is the one Qlik uses? So we don't know yet. So we gotta test it. So let me scroll down in my R code here. So I have a variable for, I'm basically trying each single type for skewness and kurtosis. So I'm not displaying yet the values. I'm just calculating, creating one variable per each. So I have basically one variable per each. And I'm applying the NARM function here, just to make sure we have that cover. So we remove no values. This is a good practice. Pretty good. I've done that. I got the values that I want to display. So let me display as a data frame. So that's what I'm doing here. Display like kind of in a table format so we can compare them. So again, I said that type 3 is the default in R. So when we did not inform any additional parameters, that's what we got in type 3. But look at type 2. Type 2 is exactly what I got in Qlik. So skewness 1.8155, kurtosis, 0.8155, kurtosis 0.6437. So if I go back to Qlik, that's exactly what I got. So we got our answers. And by the way, I tested this with other data sets just to make sure it was not a coincidence. Is not Qlik uses type 2 of skewness, both skewness and kurtosis. Great. What are type 1, 2, 3? What the actual formula? I can tell you, these are not the formula. These are like the basic, the default formulas. These are not necessarily the formulas, but I'll get you that. So what are type 1, 2, and 3? So I'll put all of these definition, everything in the article at datavoyagers.net. So, but let me explain in a very basic way. Every time that you're doing this kind of calculation, you always, unless you have the data of the entire population, which is very rare. If you do that, like it's in a census. Usually you have a sample. You don't have every single patient of a given condition in the world or in the country. You don't have every single person you're measuring the salary, the height, age, etc. You have a sample. So samples can lead to error or bias. That's why you have margin of error, because you don't have everybody. So there's a chance that you get, by just chance or by any other reason, you get more. Let's say you're measuring the height of people in the population, you're getting more shorter or taller people than actually representative to the population. So then you have a bias towards like taller or shorter people. So then when we're performing these calculations, we might have a bias correction. And so there's the law of large numbers, the central limit theorem. So there's a lot of theory that when you combine that, it tells us as we get a larger sample, as the sample size gets closer to the population, then you reduce the bias because you're closer to the population, so your error reduces. So the bias is proportionally correlated to the size of your bias, or indirect proportionally. So high is the bias, small is the sample, and vice versa. So anyway, type 1 provides us basic bias correction. So if you have small sample sizes, you use basic bias correction. So let's say, and when I say small, like less than 100, less than 150, there's no specific number because that's dependent on the size of the population. You know, how small is your sample base in compared to the population. So type 1 is basic bias correction. Type 2 is enhanced bias correction. That's the most advanced, let's say, because it's for very small sample sizes, like maybe sometimes even less than 30, or if you need higher precision, then you use type 2, which is the one Qlik is using, which is great news. It's usually the one that I pick when I'm working manually providing these parameters. And then we have type 3, which is the default in R, is when you have no bias correction. It's just whatever it is, it will show you the number. R usually defaults the parameters that are the simplest ones, because then you have the option to change it. So R does not, the approach is that R does not make the decision for you. So the default, if you don't know inform, then is the basic parameter, basically the minimum transformation as possible, or correction, and then you inform the parameter if you want to change that. Great, so these are the different types. And these are now answering the question was asked in Qlik Community. These are the formulas for skewness and kurtosis. Notice we have a few letters here. So N is the size of your sample. It's basically the count that you have. S is the standard deviation, which is a measure of how dispersed your data is. Large standard deviation means your data is very dispersed. You have numbers all over the place. Small standard deviation, your numbers are not very dispersed. They are all kind of very similar, like very close to one another, around a given number. And then we have this M3. This is not M to the third power. No, it's M3 and M4. Skewness use M3. Kurtosis use M4. What are these? We're talking here about moment. And wow, I remember that when I studied calculus and physics. Yeah. But let me simplify. What is that? So these are the central moments. What is central moments? Basically, very grotesque way to simplify and explain this is basically like reference lines in your distribution that you use to analyze something specific. So the third central moment, it's a way to quantify how asymmetric a distribution is around the mean, around the average. So basically tell us whether the data leans more to the left or to the right. Well, Igor, you told us that before. Isn't that the skewness? Pretty much. Very kind of that. That's why we use the third central moment in the skewness formula. Now, what is, I think you know where this is going, what is the fourth central moment, M4? Well, that is basically a way to measure the tailness of the distribution. So basically tell us how heavy or light the tail of the distribution are compared to the middle. Like, remember when you how stretch is that curve? So that is the fourth central moment. Hey, wait a second. You also told us this before. Isn't that the kurtosis? Well, basically, yeah. So that's why we using the fourth central moment in the kurtosis formula. So these are the formulas. These are the formula of the standard deviation. This is the formula for the third and fourth central moments. I'm not gonna go over this in detail because this would be like a series of more videos, and this video is already extremely long. So I hope you like this. I will provide everything that I've discussed here, the text, the formulas, everything in the article that will come with this video. And you can go to datavoyagers.net to read this in detail. So this is the answer for that Qlik Community post. Once again, I hope you enjoyed this. If you did, please make sure to subscribe to our YouTube channel, Data Voyagers. Follow our page, our blog, datavoyagers.net. And make sure to like this video and share it, the video or the post in Data Voyager. See you next time. Goodbye.